Next is your polar easterlies. Now as far as the direction is concerned, these are similar in direction to as that of the trade winds, right. So that is northeast in the northern hemisphere and southeast in the southern hemisphere, right. They blow from your polar high pressure belt towards the subpolar low pressure belt. These are very cold winds because they originate in the polar region. After the permanent winds, we will be coming what we call as the local winds. Now local winds are the winds which blow for a brief period of time, that is for a day or for a particular season in a very confined or local area. Okay. So for example, we have your land breezes and the sea breezes that we have discussed before. Then we have your Loo, Indian subcontinent, somewhat in Pakistan also, and we have Fohn and Chinook. These we will be doing when we discuss the biomes. So these are local wind circulations that blow in a particular confined area for a brief period. Land breeze in the coastal areas during night time, sea breeze in the coastal areas during the day time, right. So there is a table on your screen which shows some local winds in the areas where they blow. The last classification is the seasonal winds. Now what are seasonal winds? Seasonal winds are those winds that change their direction with seasons. So these are known for the reversal in their directions. A typical example is the Indian monsoon. We will be discussing this is a separate important topic when we discuss about when we come to the Indian geography portion. Right. So next we come to the shift or shifting pressure belts. One thing that we need to keep in mind from prelims point of view is that this shift in pressure belt is due to the tilt in the Earth's axis, that is 66.5 degrees with the orbital plane or 23.5 degrees with the perpendicular to the orbital plane. So this is 66.5 degrees with the orbital plane and 23.5 degrees with the perpendicular to the orbital plane. So this is the tilt in the Earth's axis. Now if this tilt wasn't there, then what we have discussed regarding wind circulations, that would have been fixed throughout the year. You would have fixed area of pressure belts not moving north or south. But because of this tilt, what happens is that when the sun is apparently vertical over the Tropic of Cancer, when you have the summer season in the northern hemisphere, all the pressure belts, they tend to shift 5 degrees northwards. Okay, so say if subtropical high pressure belt was at 30 degrees, so it has shifted to 35 degrees, right. So all the pressure belts, they move 5 degrees northwards on when the sun is directly at the Tropic of Cancer, that is during the summer solstice around 21st of June, right. Similarly, when the sun appears to be vertical over the Tropic of Capricorn during the winter solstice around 22nd of December, so all the pressure belts, they move 5 degrees southwards. All of them, they move 5 degrees southwards. So this shift in pressure belt is due to the tilt of the Earth's axis. Now this shift in pressure belt is of consequence in the Mediterranean climate. It is due to the shifting pressure belts that the Mediterranean region, it falls under the region of the westerlies in the winter season. So, Mediterranean climate is a typical climate which sees its rainfall in the winter season because it comes under the influence of the westerlies during the winter season, and during the summer season it is not in the zone of the westerlies, therefore summers are dry. Right. So, Mediterranean climate exists because of the shift in pressure belts. So, what we have discussed is the winds and the shift in pressure belts. So, we will be continuing with the air masses, tropical cyclones and the temperate cyclones.